this idea pretty good. So today is conditional probability. Okay, conditional. What does the word conditional mean to you guys?
Constant.
Conditional. Y'all remember doing conditional statements in geometry? What were those about? Y'all called them something. Y'all remember? Two words, little bitty words. Conditionals. If then statements. This is this is not really that, but it's very similar in a couple of different things. Okay, first of all, and I can't remember what I'm looking for. Uh, but when we talk about these conditional problems that we're going to talk about today, what we're dealing with is we're dealing with like a shortened group of our data, essentially. Okay, what you're going to do is they're going to put a condition on the data that you've received that actually kind of minimizes what group you're talking about. You understand what I'm kind of saying? So instead of looking at the whole data, it's going to narrow down your focus. Okay? That's what we're talking about today with conditional probability. It narrows the focus of your data or whatever that group of information that you're kind of determining probability based on. So, given events A and B, conditional probability is the probability of event B occurring, knowing that event A has already occurred. It's already occurred. So we're going to make a decision on B based on the fact that A has already narrowed my focus of my data down. Y'all understand what I'm saying? Here's what it looks like written. It's the probability of B given A. The probability of B given A. So let me just go ahead and say this. Your focus is going to be A. That's going to be what narrows down the data. Okay, that's going to narrow down where my focus is. And then my focus will change on that data specifically to find the probability of B happening. You understand? You will as we look at this, I promise. So here's the technical way of finding the probability of B given A. Okay? This is conditional probability. On the top, you do the probability of A and B. But on the bottom, you do the probability of A. You're given. Your given is going to be in the numerator and the denominator. Now, remind me about the top. What does the probability of A and B mean? Multiply. Very good. You're multiplying your probability on top, and then you're dividing by that probability of A. You're given. You're given that is going to be in the numerator and the denominator. So just looking at it, guys, what's going to happen to the probability of A in the numerator and the probability of B in the denominator? It's going to cancel, right? So I want to show you the technical way, and I also want to show you like the thinking way, all right? And hopefully the second one will make sense. But the first one is one that you can always fall back on, always. So look at this one. It says Mitchell drew a card from a standard deck of playing cards. What's the probability that he drew a queen given that the card was red? Okay? So with what I've said so far, where's my focus at right now? Our focus is on our given that, right? So what's my given that?
Red.
Yes. We're trying to find the probability of a queen given that the card is red. So let's focus on the red. How many red cards are there in a deck of standard playing cards?
26.
26 out of 52. So 26 out of 52 is going to be in my numerator and in my denominator. But up top, we're also multiplying by the probability of B, right? That first value. which is what in this case? The probability of it being a queen. How many queens are there in a standard deck of playing cards? 4 out of total 52. Remember, there's one of each suit. One queen of each suit. There's 4 suits, so 4 queens. So look what happens, guys. Your 26 over 52 in the numerator and your 26 over 52 in the denominator will do what? It'll cancel. And we'll be left with 4 over 52, which reduces down to what? 1 out of 30 or 13. 2 out of 26 is not wrong, but 2 out of 26 can go a little further too, okay? Now, I want to show you off to the left the way I like to think through it. So if I was doing my own problem over here on the left, this is what I would do. Okay, listen to this. What is the probability that he drew a queen given that the card was red? So again, my focus first is on the given that, right? So in my own brain, I start thinking to myself, how many cards is red? How many cards are red? 26. So my bottom number is going to be 26. Because I've narrowed this focus down. I'm not looking at a whole deck of cards now. I'm looking at only the which ones. I'm only looking at the red ones, okay? There's 26 of those. Now, out of those 26 red cards, you see them? Are you looking in your head? Out of those 26 red cards, how many of those are queen? 2. So, 2 out of 26, guess what it reduces to? 1 over 13. That is what is really happening in this problem. Now, that standard way of finding your conditional probability will always work. But this is what's happening. Your bottom number is getting narrowed by the given that. Instead of looking at 52 cards, I'm only looking at the red ones, 26 of them. Out of those 26, there's only 2 queens. So it's 2 out of 26, which reduces down to 1 over 13. Yes?
So depending on the numbers, it won't work all the time.
No, it works all the time. Here's the difference. Sometimes you have probabilities that are a little harder to narrow down, like I just narrowed that one down. And having that standard way of doing it is a nice fallback. Okay? It's a nice fallback. All right? So let me do number 2, the standard way, and then also let me show you how I think through it. Okay? So a number from 1 through 100 is randomly selected. So how many numbers are there, guys? 1 through 100. There's 100, right? So it says, what is the probability that it is a perfect square given that it is odd? Okay? Given that it's odd. So we're trying to find the probability, guys, of finding a perfect square. Whoops. Perfect square. I'll put PS. Given that it's odd. So I'll put O. So what's my given that, guys? What's the one that's going to be in the numerator and the denominator? No, not quite. What's my given that here?
Is it 50? It's odd.
What did you say a minute ago?
100?
No, not just 100. You need to put the 2 things you've said together. What's the probability? What's the given that probability here? Odd. Out of these 100 numbers, how many of them are odd? 50 of them, right? Half of them. So my given that is 50 out of 100. That's the value that goes in the numerator and denominator. You understand? Now up top, you have one more fraction, and that is, what's the probability out of 1 through 100 that it's a perfect square? So we have to think. Perfect squares. Isn't 1 times 1 a perfect square? 1. What's the next perfect square? 2 times 2 is 4. Next one? Huh? 9, 16, 25, 36, 49, 64, 81, 100. How many perfect squares fit in numbers 1 through 100? 10 out of that 100. Right, but see, we're talking,
Yeah.
I'm talking the standard way of doing this first, and then I'm going to show you my way, okay? Yeah. So the 50 over 100 is what I given that. The 10 over 100 is my perfect squares out of 100. These cancel, leave me 10 out of 100, which reduces to what? 1 over 10. It works, guys, okay? I know it might be a little strange, but it works. Now look, let me tell you my way of doing it. We're looking at the numbers 1 through 100, right? And we're looking at the ones that are what? Given that they are odd. How many are odd? So in my brain, here's how I would do this conditional probability. My denominator, and let me do it over here so Ellen can see it too. My denominator is 50. Because I'm only talking about what numbers? My odd ones. Now, I want you to think about your perfect squares. We just said there are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. There's 10 of them. But remember, we've already narrowed our data down to only the what? Only the odd, right? So out of these perfect squares, which ones are odd? 1, 9, 25, 49. So out of only my odd group, which perfect squares, how many perfect squares do we have? We have 5. So it's 5 out of 50, and guess what that reduces to? Same thing we just got a second ago, 1 over 10. So that is the logical thing that is happening. Again, the reason that it's nice to be able to do the old school style is because you might have some that are a little more complicated. They might have a harder time thinking through. But on problems like this, where you can kind of visualize it, then this is another really great option. Okay? Let me show you another thing that gets used a lot with these conditional probabilities. Number 3, there are 62 people that take yoga class and 48 people that take a spinning class. 15 people take yoga also, take spinning, so they do both, they double up. Okay, that's my data. All right, so here's something that gets used quite a bit with conditional probabilities. How many different categories do we really have here? What 2 major things are going on?
Yoga and spinning.
We got yoga and spinning. But I draw these circles together, why?
Because there's people that do one, and then people that do both.
That's right. So we have some overlap here, right? What's the overlap in this particular problem? How many people do both? 15. So I'll put 15 in the middle, in the overlap. Now, how many people, and I need y'all to think, are y'all with me? How many people fit in yoga only? Yoga only circle. 47 is right. Does everybody understand how I came up with 47? That's right. 62 people do yoga, but 15 of those do both. So yoga only is 62 minus 15. How many are in the spinning only? 33. Once again, there were 48 who do spinning, and 15 do both. So 48 minus 15 equals 13, or 33. So this is a circle that can kind of help me narrow things down. Okay, let me explain. Let's see what the probability asks me this time. If a person from these groups is selected at random, find the probability that he or she, and forget is, takes yoga if you know that they take a spinning class. Okay, so listen. Which one is my focus right now? Taking yoga or taking spinning class? Which one's my given that? If they take spinning class, right? Let me read this one more time. Find the probability that he or she takes yoga if you know they, given that they take spinning class. So what circle am I focused on? The spinning circle. If I ignore the yoga circle, how many people are in the spinning circle? Huh? How many people are in this whole circle? 48. 48 is my bottom number. That's what my group has been narrowed down to. Now, of those 48, how many take yoga? 15. So my answer is 15 out of 48. That's another method that people use to look at their data differently, okay? You understand that? Yeah?
Would you simplify it?
Can it? Yeah, 3 goes into both, right?
That's 5/16.
Yeah, 5/16. That's right. Yeah, if you can simplify it, we want to simplify it. All right, does that make sense? Okay, we're going to go down to the last part. It's called the two-way tables. And I love these. I think the two-way tables make things really, really simple because it helps you to narrow your focus down. So I want you guys to look at this. A, it says probability that they do what? Prefer football. What? What's that little line mean? The probability that they prefer football given that they are a girl. Remember, our focus has to be the given that, right? So this is how we narrow down our data. It's given that they're a girl. So what group am I focused on right now? I'm only focused on the girls. So what's my bottom number if I'm only focused on that group? 22. That's my bottom number here because those are the only ones that are girls. 22 people are girls. Now, from that group, how many prefer football? So my answer is 6 out of 22, which will reduce, right? To 3 out of 11. That's how you do this, guys. The given that is your focus. That's what narrows your data down. Okay, look at the next one. What's the probability that they're what? A boy. Given that what? They like hockey. So where's my focus at in my data? Nope. Given that they prefer hockey, right? That's my focus. So I'm only looking right here. That's my focus right there. So what's my bottom number? 26. Does this make sense, guys? So sometimes your focus can be your vertical column. Sometimes it can be your horizontal. You understand? Now, out of the group that prefer football, or I'm sorry, hockey, out of those 26, how many are boys? So it's 10 out of 26, which will reduce to what? 5/13. Yes, ma'am.
What is the difference between like how did you get like for the preferred football girl? Why did you go vertical and for the boys you went horizontal?
Okay, because the given that is your focus, and in this letter A, it's given that they're girls. So my focus is the girls.
Okay.
But in the B, my given that was hockey, so my focus was hockey.
Okay.
So that given that is what narrows your data down to that particular section of things. So does that make sense?
Yes.
That's why we only looked at the vertical column that first time because the given that was the girls. But we looked at the horizontal because the given that was the hockey.
Okay.
So that given that is the key. That's where you go first when they say given that. Okay? Now, let's go immediately to the next problem, and I want you to look at A here. Does this say a 7th grader given that they take French?
No.
No, it just wants you to find the probability of a 7th grader who takes French. So how many people are 7th grade and take French? You have 25. Out of who?
All 7th graders.
Out of all 7th graders. How many 7th graders were there?
57.
No, I'm sorry, not all 7th graders.
This is everyone.
Out of all students.
150.
So it's 25 out of 150. So you didn't narrow your focus down here because it didn't give you a given that. It just says, what's the probability of getting a 7th grader who takes French? You understand what I'm saying? There was no narrow. There was no narrowing. There was no focus on my data. Now, 25 over 150 will reduce to what? 1? No.
1 over 6.
1 over 6. Now, look at the next problem, though. You're wanting to find the probability of an 8th grader, what? Given that they are, what? Taking Spanish. So what's my focus? Taking Spanish. That's where I'm focusing my data on the taking Spanish. You understand? So what's my bottom number? 23 plus 12 plus 33 is 68. Now, out of that group, out of that focus, how many are 8th graders? 33. And I don't think that reduces, does it? Okay, look at the next one. Look at C. The probability they take French, given that they're what? 6th graders. What's my focus? 6th graders. So how many are those? How many 6th graders do we have?
42.
So out of those 42, how many take French?
19.
19 over 42. You see that? That's why this conditional probability is not hard, especially in a two-way table. It's giving you the given that narrows your data down to that specific group. So look at this last one here. The probability that they are a 7th grader, given that they take French. What's my focus? French. That's 19 plus 25 plus 38, which we added a second ago, didn't we?
No.
We didn't. That's 82.
We did the Spanish stuff.
That's right. We did Spanish. Now, out of that group, how many are 7th graders? So it's 25 out of 82. And it doesn't reduce. Does this make sense? Y'all good with this? All right. If we looked at this next group, which we won't, just remember, y'all see a given that in this problem? So this is simply asking you for a junior who did go to the prom out of the total. It has to have that given that to narrow your data down, okay? If not, it's pulling it from the whole group. You understand? Okay, so your homework assignment is going to be 2 through 14 even. Now, it sounds like 7 problems, and it is. It is 7 problems. But you have a couple of them that are like that. It's a table, and you have to answer a couple of questions based on that table. But they're easy, right? Y'all can do this. What do y'all think? Easier than yesterday or harder? Easier?
The tables.
Yeah, I can see how that could get.
You said through 14.
Yeah, 2 through 14, even. 2 through 14, even. 2 through 14, even. Again, tomorrow, what I've decided to do is we're going to review tomorrow, and then you're going to have a Google form quiz on Friday that I would prefer you to do on Friday, but it's due the Sunday before we get back from spring break. Again, I encourage you, majorly encourage you to do it over or on Friday. because if you don't, you might very well forget. So my recommendation for sure is for you to do it Friday. It will be available first thing Friday morning. Okay, hey, good luck. I hope it's not too bad.
What's today's date?
Oh, crap it. I need to turn this recording off. Today's date is